Like last time we left off, I had made an interpreter. uh, I made some changes to that. Firstly, like I've added I think debugging, like more debugging. I've also added some system call sort of things, so like functions which you might want to add to like extend these things. So this is like base class for system calls. So you can have user input, you can have like appends to lists, you can have pop outs, getting the length of a list or a dictionary, getting the keys, etc. So everything that Python allows, you basically have that inbuilt in this language because it's basically made on Python. So like for the interpreter part, it's pretty doable. But that's not what we are here for, because the course is named compilers, and compilers will compile. So I want to show like how does this language compile into something. So I'm just going to have some very simple code. So you have this thing, so you just start defining two variables, s and x. You're defining it as 0 and 1, and then you are doing this stuff. So this is basically the first project order question. It's not complicated at all. The logic is pretty simple, but like if you had to write this in like programming in an assembly language, how would it look? So what we can do is we can do so Python 3, and there's this try.py script that I've written. So this is testing, it's not important, which you can just use. And yeah, so we just have try.py, and so this generates this assembly code. And just to like show this like is not something else, so I just delete it, and sometimes you have to load it. Yeah, so this is assembly code, MIPS basically, which is a problem because like my computer works on x86, so I really can't use it like on my system. The good thing is we are probably going to use it on a virtual machine anyway, so we'll be like making our own virtual machine for some I don't know, like very simple operations, but we are going to base it on MIPS. So like this is basically the code that you would have. So how do we test whether or not this code is correct? I built the code so that it can be easily run on this very nice simulator. So this is called CPU later. So I'm just going to paste all of my code in this, and I'll just do compile, and it compiles. So it compiled successfully. It has some weird things where it like throws errors where like I do not intend there to be errors, but I'm just gonna go over it. So continue. So weird thing is like continue just runs the whole thing till like it stops. So yeah, there you go. So this is the answer, like this is what it prints when you have. So this, where did it go? Yeah, try.txt. So this last thing, print s, this basically prints the same number, and I can show that easily. So it's like just Python, I don't want that. So I can also run it the normal interpreter way. So just run.py and then the file name, so try.txt, and so this is our program, this is the output. So 233168, which is the same output that we got on this terminal. So it's 233168. So this is just basic, like this is very basic. In fact, there's no like functions or stacks or calls or all sorts of things, but you can actually have stacks and calls and all that. So I'm gonna give you one very basic sort of thing. So it's let's say you define two functions. So it's like let f, let g, right? And then g does, I don't know, g does something. So it's an algorithm. So what it does, it is it, let's say, just returns 2 times of x, right, where x is the input. I don't know, just some random function. Okay, and f is I don't know, maybe something which adds 1 or 2 based on the parity of x. That's a possibility. So yeah, so it's like an algorithm. And you can't follow the semicolons. So So it's gonna call some another function. So let's say call some function h. So what it will do is it will say let y be equal to h of x, right? And then it will say, so if I don't know, y remainder 2 is 0, we'll just, I don't know, print something. So this is like print 1, right? Else we'll print something else. So it's like, or don't print anything else. So whenever you have, or just print y itself. And this is going to happen obviously because of the way this thing is. Or what, let's just say it's like just not say 2 times of x, but rather what should I put instead? I guess x cubed, or I'm just gonna put x cubed plus 1. Hey, that's actually very easy. For 2 it's kind of easy. Let's put something interesting. Think about it. I can just put x cubed minus x, right? This is gonna be x cubed minus x. Alright, and that's what it returns. So sure, we know that's gonna be multiple of 3. So let's just say if this is a multiple of 3, then we'll print y, otherwise we don't print anything. Alright, cool. And just for the sake of consistency, let's return something. So I'm gonna return 0. Now you can say, okay, I'm gonna let's just make another variable. So it's like let out, I don't know, just something. So the problem with that is I've actually made run statements till now. So like I can just run using a function call and not assign it to some variable. So that's the problem over here. Anyway, so you have out is f of so it takes in 2 arguments. So let's say x comma g, right? Yeah, so g, as you can see, this will be like some sort of object sort of thing, and then this is going to be like whatever the output is. So this is going to print stuff for us anyway. We don't need to print anything, but it's just, so if I had to run this normally, okay, undefined variable x. What do you mean undefined variable x? That's kind of weird. Hey, this is unexpected. Undefined variable. Why x? Well, oh, this capital X thing. Oh, okay, so this is actually not defined. Yeah, you're right. Let's just say it's 10 or something. Cool. So this gives 990. We kind of wanted to print new lines, but whatever, it doesn't really matter. Yeah, cool. So just to think about it, so you had 10. So like y is h of x. So h of x is basically this thing. Okay, cool. And then yeah, so it printed. Otherwise it just prints nothing, right? Okay, cool. And then it returns 0. That's cool. So so yeah, 990 is this thing. It's just x times of x minus 1 times. Sure, it's the thing. Okay, and it's gonna print for everything because obviously this is like a divisible by 3 thing. But yeah, what we're doing, we wanted to run this using assembly, so it's like, I'm gonna clear this first. So it's like Python 3. So for assembling this, we'll just have the try.py. So this is already in try.txt, so you can easily do this thing. And so this is not implemented yet. It's saying, okay, so the power function isn't there yet. No big deal, we can just have this thing. That's probably doable. Cool. And so yeah, I can actually implement the power function. It shouldn't be such a big deal. This is the fast explanation method. But anyway, so what assembly code did we get? This thing. So I'm just gonna put that in this editor and compiled. Succeeded. And I'll just continue this. Yeah, whatever. I don't care. Just alright. So it exited. Cool. Oh, the terminal was already having something, so I should have probably cleared it. Okay, so restart that, continue. So this is going to throw some errors because of some weird things it has, but anyway. So yeah, it also printed the same thing, 990. And so if I want to disable this thing, I can disable that as well. So this is because of like changing the values of the registers. So yeah, you're not technically supposed to be changing the return address register, but well, since this is kind of my own thing, I can do whatever I want. You can't really tell me to not. So I'm gonna restart and run that without any errors. Okay, why did it still throw errors though? Oh, because that was for interrupts. Sorry. So not interrupts, I wanted in general. So function clobbering, yeah. Okay, restart, just continue this thing. So yeah, so syscall 10 just exits the whole thing, and so it just printed the thing twice. It's 990. Cool. So this is going fine. Now let's get to the code. Okay, that was weird. Alright, let's get to the code. So this is just the output, like the assembly output that we have, and it's ugly, it's really bad. But one thing you can notice is that it's basically made up of these blocks which do things. So this is, for example, like this, and a lot of things beneath it in fact are part of what's called an algorithm block. So basically it defines an algorithm and then puts that as a topmost level on our stack. So a stack is basically something I'm maintaining on my RAM that I've been given, like the part of RAM that is usually used for stack. I'm just using that exactly like a stack, except not using a stack pointer. Yeah, I kind of don't like doing that. I'm just going to use like my own base registers. So it's like S1, S0, whatever. So S1 is basically the stack pointer, and S0 is something like the frame. I don't know, it's not exactly used like that, but it's some sort of it shows like that for the current function call, where's the base level, right? Which also contains in fact the link to the previous level, so it's very easy to just figure out where the variables are and all of that. Yeah, so this is how I make a stack frame. I have this helper pathfinder function. So this just returns the return address value for, so like wherever I call this, it will just return this thing's address, right, this instruction's address, and then I can do some crazy stuff with that, like change the value and whatever, and then, like, you know, make it jump to some arbitrary instruction which I want. Now you might say, why not use labels? The problem is, like, with labels you have to keep assigning unique labels all the time so that it works correctly, and also it puts a lot of load on the linker and all that. So like, let's just skip that whole thing and use this sort of function. And I know this is slightly slower in runtime, but who cares? Yeah, so one thing which is still missing is like self recursion and other optimizations which usually are done in a compiler, which, you know, you can't do in an interpreter right away. But yeah, more or less this is done. So currently what's available is using functions as objects, lexical scoping, right? You can have multiple frames basically, recursion obviously, self recursion is missing, eval time referencing to like non-local variables, that's something which is missing. I also don't have closure right now. I'm still figuring it out. I do have lists. That's one nice thing that I've put. So I have lists somehow. I always implement that at the first. So it's like, let's say let L, and we'll just say L is a list of 4 elements, and we can just say like, okay, L0 is equal to 1, L0 equal to 2. So this is basically just on the heap. This is not 0, this is 1, and I don't know, L2 equal to 3. I'm just just putting it arbitrary values. It could have been anything. I just like sequences, that's what. So yeah, then what I want to do is basically just print these things. I'll be like printing, I don't know, L0 plus L4 or something, I don't know, just some random thing, it doesn't really matter. So what I can do is first I can just show you the output. So it's like you just run it normally. So this is like what, try.py. Oh, come on, right. Oh, okay, what, list 4 L0 1 2 3 4 L4 print. Whatever happened? What do you mean you can't lex? Okay, my lexer is broken. That doesn't make any sense. That should not. Oh, okay, it's try.py, which that was bad. So try.txt, list index out of range. This should be a list of 4 elements. I don't know why. Oh, because L of 4 is not there, so that's why. Alright, so this outputs 3, which is obvious. It's like just 1 plus 2. Okay, now let's do this using assembly. So I'm gonna clear this first. I'll be like python 3, what's the command again? Try.py. Cool. So I'll have code over here and I can just copy paste that, and I hope so this is going to work. Okay, so basically the $S5 register, it stores like it basically works at malloc. Whenever you have a list assigned to some variable, it's basically like the variable is a pointer to something on the heap, and the heap starts at our $S5's value, right? So I'm just gonna continue this like straight up. I really should just start, what, I should just put like a clear system call thing, but whatever. So I'm gonna restart and continue it. Okay, so prints 3, but the thing that I want to show you is, so okay, this is really bad. I don't want this wordy thing, so this is a word. Actually, I want a decimal signed and make it 1. Right now S5 is where the this is always happen, that's where the logic is. So so S5 actually starts off at 40004, so this is a hex value. So it starts off at this address, but then since I've assigned 4 words to the list, so basically like the list is now pointing to this, so the list is basically a pointer which is pointing to this thing, and the S5 thing has gone over here. So this is S5's current location, or where it is pointing to. Cool. This thing 4000, this is actually where S0 was initially pointing to. So S0 is our base register for the stack. So you have the stack, you have the heap, and yes, this is a really unsafe combination because I put them like extremely side by side, but whatever, I don't care. Yeah, so this is it, I think. I also have like cool input stuff now, so maybe I can show that instead, like instead of just quitting. So you could just have like, I don't know, you could just have x. How are you? Right, pretty nice. And then I don't know, I'm just gonna take input. You could just print it if you're really like, you could even skip the whole bracket thing, who cares. But yeah, so I can just do like python 3 .py, and then just, what was I going to do? What is this file? Oh yeah, try.txt, not py. I am sleepy, that's why this is happening. So how am I? I am good. Whatever. Yeah, so now I have user input and all of that. I also have the turn plot lib thing, so like it supports visualization. what other system considered? I also have read write from files, so like I could just literally do, I don't know, so it's like let s be equal to, so I can just have the file thing, so it's like let file be this thing, so it's just try.txt, and I'll be like read this file. So yeah, you have to put semicolons. Alright, so and then I'll just be like print as, yeah, I just like printing stuff, and so it's gonna print this thing basically. As you can see, so this just read this file, and you could even like do some crazy things like write it to the same file, which should be weird, but you can actually do that. So you can do like a write, have the same file, and since you have printed it anyway, so it's the same thing, it doesn't really matter. Yeah, okay, this, I think that's not how the command works, huh? You can get it assignment. Oh, so it's like the return code is this thing. Yeah, it needs to give a return code. I think this is correct. File comma s is how it works, right? Yep. So it literally just wrote to the same file, but you didn't see anything because it happened instantaneously. So yeah, this is, I mean, okay, if you are still doubtful, might as well see. So yeah, this is it. So I'll see you guys in the next video.